Hello, welcome to the sixth of the quickies, finding good names for your intents. This is a quickie where we start with syntax and advance through semantics. First of all, what is an intent actually? Intent recognition is a popular task of NLU that is commonly used for chatbots and question answering. Intent recognition is the task of classifying a spoken or written user input based on what the user wants to achieve. Then, according to the intent, your bot gives an answer or produces an action. Hence, intent recognition is a special sort of text classification. These are some examples. So, an intent is basically name of a class. This quickie is about determining good names for intents in your NLU pipeline. Good intent names are essentials for intent recognition. If intent names do not reflect the semantics of the user import, it's a confusion source, first of all to yourself and to the rest of the pipeline. Imagine you have an intent name called show. So, show what? Show the time, or show the calendar, or show my email box. Not restricting the intent name, hence the intent semantics with a well-defined object causes NLU to do more parsing rounds to extract the semantics. Hence, we want to hit the intent semantics at one shot. In order to find a good intent name, we will extract transitive verbs and their direct objects from utterances. We do it in 3 steps. First, we will refresh our knowledge of transitive, intransitive verbs and direct, indirect objects. Second, we will extract the transitive verbs and the direct object of the verb by working on the dependency tree. Third step is devoted to extracting multiple intents and dealing with some tricky dependency trees. Let's get started. A verb is a very important component of the sentence as it integrates the action in the sentence. The object of the sentence is the thing or the person that is affected by the action of the verb. Hence, there is a natural connection between the sentence verb and the objects. The concept of transitivity captures verb-object relations. A transitive verb is a verb that needs an object to act upon. Here are some examples. In these example sentences, both, loved and borrowed are transitive verbs. In the first sentence, both is the transitive verb and flowers is its object, the thing that has been bought by the sentence subject, I. Loved, his cat, and borrowed, my book, are transitive verb object examples. We will focus on the first sentence again. What happens if we erase the flowers object? Look at this sentence. Both, what exactly? Without an object, this sentence doesn't carry any meaning at all. In the preceding sentences, each of the objects completes the meaning of the verb. This is a way of understanding whether a verb is transitive or not. Erase the object and check whether the sentence remains semantically intact or not. An intransitive verb is opposite of a transitive verb. It doesn't need an object to act upon. Let's see some examples. In all the second group sentences, the verbs make sense without an object. If we erase all the words other than the subject and the verb, these sentences are still meaningful. The object is the thing person that is affected by the verb section. The action stated by the verb is committed by the sentence subject and the object gets affected. An object can be direct or indirect. A direct object answers to questions whom, what, opposed to indirect objects answering to whom, for whom, to what, for what. Here are examples for each group. Okay, now we can extract the verbs and their direct objects. In this tree, the transitive verb is find and the direct object is a flight. The relation d-obj connects the transitive verb to its direct object. If you follow the arc DOPS, we can merge find and a flight into a single word, find a flight or find flight. In this sentence, there are other two objects that are marked by POBJ relations. POBJ means object of the preposition, hence burden and ROM are indirect objects. Let's do it with code. We will first spot the direct object by looking for the DOPS label in the sentence. To locate the transitive verb, we look at the direct object's syntactic head. A sentence can include more than one verb, hence we are careful while processing the verbs. Here is the code. Some utterances can carry multiple intents. For example, consider this user utterance. Obviously carrying two intents, listing the flights and listing the meals on those flights. Let's see the dependency tree of this utterance. We see that the DOPS are connects show and flights. The conjure connects flights and meals to indicate the conjunction relation between them. The conjunction relation is built by a conjunction such as and, or, so on, indicates that a noun is joined to another noun by this conjunction. In this situation, we extract the direct object and its conjuncts. Let's see the code. Here, we looped over all tokens to locate the direct object of the sentence. When we found the direct object, we obtained its conjuncts. After that, we extracted the direct object's head to find the transitive verb. After extracting the verb and two objects, if we want, we can combine the two to create two intent names, show flights and show meals. Though intent recognition looks like a purely semantical task, lots of syntax is indeed included. Remember, for designing a good NLU pipeline, you should attack with all the weapons you have. Luckily, you are here with us today enjoying the quickies. Thank you for joining once again and looking forward to meeting you in the next quickie. Until then, bye bye.